Let's answer this example before us. Suppose that the probability that a family in a certain town owns a television set is 0.75, and the probability that a family owns a station wagon is 0.25. If these events are independent, find the following probabilities. So we're assuming independence here. A family chosen at random owns both a television set and a station wagon. So this is asking about the intersection point. So the probability that T intersects S, they have to own both of them. We know that because we're dealing with independent events here, we can use our independent rule, which tells us the probability of T times the probability of S is going to be equal to the probability of T intersection of S. So that's going to be 0.75 times 0.25, which is equal to 0.1875. Remember, the only reason we could use this is because we were told to assume independence. So I'm actually going to write a little note here as T and S are independent. If they weren't independent, we could not have used this rule. I don't think using is a word. It definitely isn't. We couldn't have used this rule. Okay, next. A family chosen at random owns at least one of these items. Now, we're not finding intersection here. What are we trying to find? Well, what we're finding here is T, the union of S, because they either own a television set or a station wagon. They don't need to own both, they just need at least one. So we're thinking of or here, and that's union. Remember, when you have to find union, we're going to think for a moment, what can we use? The addition rule always works here. So we're going to go the probability of T plus the probability of S minus the probability of the intersection. T is 0.75 plus S is 0.25 minus 0.1875, which means my answer is going to be 0.8125. A lot of numbers. And there we go. That is how we do it.